Hello and welcome to this lecture series on processing of textile fabrics on a Stenter. So this is the first part of a series of lectures on Stenter frame, and in this particular lecture we are only going to cover an overview of the Stenter. We will briefly talk about the different uses of a Stenter, its main parts, and of course we will cover the working in general. However, in the subsequent lectures in this series of lectures, all the different aspects will be covered in more detail. So a Stenter is one of the most versatile machines that is used in textile processing. We can use a Stenter in the pre-treatment line if we want to improve the dimensional stability and control the shrinkage of fabric. This is probably one of the most widespread uses of a Stenter, and we process the fabric on a Stenter to achieve these aspects in the fabric before it is dyed or printed. We also have to set the width of the fabric before it is dyed or printed, because whenever a customer requires us to prepare a fabric in an open width form, they specify the required width of the fabric as well, along with some tolerance. So a Stenter is capable of achieving that final desired width of the fabric. As we have seen in the previous lectures, Stenter is where we have an opportunity to remove the weft distortions as well. But in addition to that, a Stenter has found several other uses as well. So if a Stenter is employed in the finishing line in a processing industry, then a Stenter is very commonly used for chemical finishing of textiles. It is even used for dyeing of textiles, but then usually it's limited to pastel shades. Stenters are modified considerably and used for coating of textiles as well. So, and then sometimes even for just drying purposes. So let's say if the other equipment, for instance, the pad steam machine or the other let's say washing range, they are under a lot of production load, then the fabric can be brought onto a Stenter just for drying purposes only. Although one can argue that that's probably not a very good use of a Stenter. So it's the first three that are usually considered as the main applications for a Stenter if the Stenter is used in the pre-treatment line in a textile processing industry. So let's look at a typical layout of a Stenter. Stenter is one of the largest, or you can say the longest, machines in the textile processing sector, and it has a number of different modules in it. To get an idea of the scale of the machine, you can see if this is the operator, then that's the extent of the machine. So it's a fairly long machine. And this part over here, that's the actual or the typical Stenter frame. But then before the actual Stenter frame, we can add a number of additional modules to make the Stenter more functional, as it was mentioned in the previous slide, that it can be used for several different things, including dyeing and finishing and coating, etc. So just before the actual Stenter frame, we can add additional modules such as padders if we are using the Stenter for chemical finishing or dyeing. We almost always have weft straighteners that are installed as a part of the Stenter frame, but they are actually not a part of the Stenter frame. We can have a number of other modules like evac systems for chemical impregnation. We can even have IR dryers. So the whole point here is to just understand that a typical Stenter frame can be made very versatile by adding additional modules depending on what you're trying to achieve with the Stenter. In the rest of the lecture and in the subsequent parts of this lecture series, we are going to discuss about a Stenter from the perspective of pre-treatment operations only. So I will not be covering padders, evacs, and IR dryers, for example. So let's now focus on the main section of the Stenter, and let's see what zones are there. So we usually divide these long machines into different zones, as it helps us in understanding the way the machine works. So in a Stenter, we have the feeding zone. That's from where the fabric is fed to the machine, and we will talk about how it is done in detail in the next lecture. We then have the treatment chambers. That is where the actual process takes place. And then we have the exit zone from where the fabric leaves the machine and it is stored in a desired form. So let's look at a video which is courtesy of FA Industries Turkey. You do not need to focus too much on any of the parts, but the video is just to help you get an overall idea of how the Stenter frame looks like and how the fabric is transported through it. So this is where the fabric is entering into the machine, the treatment chambers basically. And then the treatment chambers are provided as a set, so you have multiple treatment chambers. Again, this is something we will cover in one of the following lectures. This is the entry section. The fabric is fed in open width continuous manner. This is the section where the salvages of the fabric are gripped and the fabric is carried through the treatment chambers in this manner. So this is where we have the auxiliary units, the entry zone. The fabric has to be crease free and we have to adjust the tension in the fabric, as we have to do in all open width continuous processing machines. Immediately after the in-feed zone, once the fabric is brought in completely open width form, it is passed on to the padders. But because padders exert excessive pressure, there are multiple devices that are used in the in-feed zone to ensure that there are absolutely no creases in the fabric. Again, the focus here is on the padding units. You can use these padders just to apply water on the fabric, or you can apply chemicals, finishing chemicals or dye liquors onto the fabric. So the typical J spray unit, which is a part of every open width continuous processing machine, to allow us to achieve that batch to batch change without stopping the machine. So here you can see in this video they are referring to finishing padders basically. That's the typical construction of a continuous padder. You can see a trough and the fabric is immersed in the trough and then squeezed. We can see that in this particular video, the Stenter that they have shown is actually a dyeing Stenter. So you can see the fabric is dyed blue. Again, these driven expanders to ensure that there are no creases in the fabric. We use multiple expander devices in long machines because creases can be a complete disaster for us. Now the focus here is the weft straightening unit, which has been covered in one of the previous lectures that I've uploaded. And then this is the actual start of the Stenter frame. So this is called the gliding mechanism. Here the salvages of the fabric are gripped in chains and the fabric is transported through the treatment chambers. So yeah, they are showing the control panel here, which shows you the temperature and the humidity that is maintained in the treatment chambers. This particular section is the gliding mechanism. Again, I will refer to one of the subsequent lectures in this series of lectures. You can watch it to understand the complete working of the gliding mechanism. This is the gliding mechanism here in focus. So it is just the salvages of the fabric that are gripped as the fabric is passed through a Stenter, and this is probably the most important aspect of processing a fabric on a Stenter, because we do not carry the fabric in this manner on any other machine. And it is this very action of holding the fabric salvages that allows us to adjust its width and achieve the dimensional settings that we usually use a Stenter for. A set of treatment chambers and then Again, this is covered thoroughly in a separate lecture, so we are going to move ahead now in this lecture. So let's look at the working of a stenter in general and how the fabric is processed on a stenter. So the unique feature of processing a fabric on a stenter is that when a fabric is processed on a stenter, it is held from its selvages, and in this state it is transported through multiple treatment chambers in which the process conditions are maintained. We will be covering this in detail in a separate lecture in this series, but briefly, maintaining the process condition means maintaining the required temperature and moisture content, etc., according to the process requirements. Now, I will emphasize a bit more on this very action of holding the fabric from its selvages as the fabric is passed through the stenter frame. It is this action of holding the fabric from its selvages that allows us to adjust the width and length of the fabric as desired. So just imagine a flexible sheet in your hand, and if you want to stretch it widthwise, you will have to compromise on the length of the sheet. On the other hand, if you want to stretch a flexible sheet lengthwise, then you will have to relax it widthwise. So this provision of holding the fabric from its selvages on a stenter allows us to achieve this sort of action. In this image on the slide, what you are looking at is the entry section of the treatment chambers, and you can see that the fabric is only secured from its selvages. It's not passing over rollers, as you will see in a number of other processing machines. Now, processing speeds could vary considerably, and modern stenters are designed to process fabric at speeds exceeding 100 meters per minute. The temperature that we can achieve in the treatment chambers is again one of the main factors, and modern day stenters allow you to achieve and maintain temperatures of well above 200 degrees centigrade depending on what sort of process you are carrying.
So if we now talk about the parts in a bit more detail, we have the entry arrangement, as I've mentioned in the previous slides. The entry arrangement is very similar to the entry arrangement of any other open width continuous processing machine. So in case of a batcher entry, we have the unbatching arm, J scray, etc., edge guiders or the spreader rollers for crease removal, compensator for the adjustment of speeds of different rollers, and of course a lot of guide rollers. We have padders or a dip trough, the weft straightener, which has been discussed in detail in the previous lecture, and the actual um, start of the stenter is from the fabric feeding mechanisms. We then have the treatment chambers. We have a cooling zone in a stenter and the fabric exit section. In the following slides, we are going to talk about these parts in detail, starting from fabric feeding mechanism. Now, notice one thing. Okay, we can have heat recovery systems, but these are optional. Now, the description of the parts that I'm going to present in the following slides is specifically focused on stenters that are designed for processing of woven fabrics. For knitted fabrics, the stenters are slightly different. The main frame of the machine remains the same, but of course there are some additional provisions to handle the high extensibility of knitted fabrics. So keep it in mind that the parts and their description that we are going to talk about in the following lectures is specifically for the stenters that are designed for woven fabrics.
Let's look at a summary of what we have discussed about stenters in this lecture. So, on a stenter frame, a textile fabric could be processed for various reasons. Commonly, a fabric is processed on a stenter for width adjustment that is usually required prior to any subsequent processes such as printing or dyeing. Processing of a fabric on a stenter also allows us to achieve dimensional stability by controlling the shrinkage of the fabric. This is done by treating the fabric with the right temperature and moisture content to stabilize its dimensions. The unique feature of processing a fabric on a stenter is that on a stenter, the fabric is held from its selvages as it is passed through the machines, essentially through the treatment chambers. And this very action of holding the fabric allows us to adjust its width and length and achieve the required dimensional stability. The other main feature of processing a fabric on a stenter is that the lengthwise tension in the fabric can be changed. And this is crucial because if you are increasing the lengthwise tension on a fabric, then the width will be reduced. On the other hand, if the lengthwise tension on the fabric is less, or if it's slack, then you can stretch a fabric widthwise. The fabric is passed through multiple treatment chambers, and this is where the processing conditions are maintained and the desired results are achieved. Thank you for listening to this first part of lectures on a stenter. In the subsequent lectures in this series, we are going to talk about the different mechanisms and how the stenter works as a machine.